problem, we're supposed to compute the outward flux of the vector field f of x and y and z equal to z, y, and x across the unit sphere x squared plus y squared plus z squared equal to 1. Unit sphere is a closed unit sphere. Unit sphere being a closed surface, it reminds me of divergence theorem. Divergence theorem says that the flux, which is the vector surface integral over the sphere, which is a closed surface, is going to be equal to divergence, a triple integral of divergence of f over what is inside this sphere. If this is the boundary, if this one is the boundary, this one is the region, which is a three-dimensional solid. Now, let's compute the divergence of f. So, and so the divergence of f, which is the dot product of the nabla operator and the vector field, is going to be ending up to be, this is 0, this is 1, and this is 0, is going to be 1. So in here, if I'm computing the divergence of f, which is 1 dv over the ball inside the sphere, I'm basically just finding the volume of sphere, which is 4 pi r, which is 1 to power 3 divided by 3. So 4 pi third. And this is the easiest way of computing it using divergence theorem. You can compute this directly. It's always basically if the surface is not closed, you may have to compute this directly, and that's the next example.